All right, for this very last video of Unit 6, what we need to talk about are the molecular formulas. You've already learned about empirical formulas, which again is the lowest whole number ratio of a particular compound. What we're going to do now is calculate the molecular formula, which is going to be multiplied up to a larger value. What we need to do is figure out just by what factor do we multiply it up, okay? So what we're going to do for number 4, it says determine the molecular formula of a compound whose empirical formula, which again is the reduced one, is C3H2O2. Notice you cannot reduce C3H2O anymore, any further lower, because again, it's already the empirical formula. What they do give us, and they're very generous, is they give us a molar mass is 216 grams per mole. Now that 216 grams per mole is not the molar mass of C3H2O. That is the molar mass of the higher, larger molecular formula. So what we're going to need to do is find the molar mass of the empirical form, the C3H2O, find its molar mass. Then we're going to do what it says at the top of the screen. We're going to divide the molecular, which they gave us, 216 grams per mole, divided by what we calculate as the empirical molar mass. And then that, when we divide that, will give us a number which we will multiply C3H2O by to make it into a larger compound, okay? So let me show you what I'm talking about. What we need to do again is we're not going to use the 216 yet. What we need to do is find the molar mass, find the molar mass of C3H2O. So C, of course, the mass is 12.011. The mass of hydrogen is 1.008. The mass of oxygen is 15.999. Then we're going to multiply by how many there are, because again, this is molar mass. There's 3, there are 2, and there are 1. So 15.999. Again, I'm just looking at this right now, just so you understand what I'm doing. 2.016. And this would be what? 36.033. Okay, then we're going to add those together, of course, because that is what molar mass is. Okay, the total mass of this particular compound in the present ratio of 3 to 2 to 1 is 54.048 grams per mole. Okay, so what we're going to do is we're going to take this mass here, 216 grams per mole. We're going to divide by this number here, 54.048 grams per mole. And we're going to find out what is the factor which we need to then multiply everything by to get it up to its molecular form. So divided by 54.048, what I get is, whoa, I did that wrong because I multiplied. Let's try that one more time. Okay, so what I get is a 3 point, man, sorry guys, that's supposed to be a 3. 3.996, okay? So 3.3996 is basically 4. Okay, again, this is kind of weird because we have to kind of make a little bit of leeway in the math. So that means it's 4. So we're going to multiply our compound by 4 times larger. So the final answer is not C3H2O. Again, that's the lowest whole number ratio called the empirical. We're going to multiply all those numbers up by 4. So C3 becomes C12. H2 becomes H8. O1 becomes O4. There is our final answer. We basically did this times 4. That is the molecular formula for this particular empirical formula if the molar mass is 216 grams per mole. Okay, let's try number 2. So they gave us the empirical formula as number 5. B2H5, and the molar mass is 54. Again, that molar mass does not relate to that. Okay, that's a different molar mass. I know it's a little confusing. They're not giving us the answer. They're just giving us the information we need to get to the answer. So B and H, the mass of boron is 10.812. The mass of hydrogen is 1.008. I'm going to multiply by how many there are. There are 2 of those. And there are 5 of those. That's going to be what, 5.040. And this is going to be 20 something. I don't want to embarrass myself right now. 21.624. I'm going to add them together because I need the molar mass of this particular empirical formula, 5.040. And that gives me 26.664 grams per mole. Okay, so again, they tell us that the molar mass of the molecular compound is 54. I'm going to divide that by 26.664, and what I get is 0.25, which again is pretty dang close to 2. So what I'm going to do is I'm going to multiply the empirical formula, this right here, by 2. So instead of B2, it's now B4. Instead of H5, it is now H10. That is my final answer. That is the empirical formula, B2H5, multiplied up double, because the ratio of the molar mass of the molecular to the molar mass of the empirical is twice as big. All right, the next one we have is we have C, H, and Cl. The mass is, of course, 12.011, 1.008. This is about 35, 35.453. Multiply by 1, multiply by 1, multiply by 2. That's going to be 24.022. That's going to be 1.008. That's going to be 35.453. Going to add them together, of course. 26.022 plus 1.008 plus 35.453 equals a total molar mass of 62. Sorry, my pen does not work very well on the bottom of my screen. 483. That, again, that first digit is supposed to be a 6. I do apologize. Let's try that one more time. 60. Oops, yep, 60. Okay, that's not going to work. 62. Okay. Anyway, the molecular formula mass is 179. This one is 62, or squiggle 2, 483. I'm going to divide those two numbers, 179 divided by the previous answer. Oops. 179 divided by 62.483. And I get, it doesn't work out quite as nicely, does it? It comes out to be 2.86. 2.86. That's not quite ideal. That's not as close to 3 as I would like it to be. Yep, that's the right answer. I just did double checked. So if that is going to be a 3, which again, it's not really close enough that I really feel confident about this. Again, instead of C2, it'd be C6. Instead of H1, it'd be H3. And Cl would not be 1, but 3 as well. So again, that's based on that formula right there. Okay, guys, that's how you do the molecular formula. All right, guys, well, thanks for watching. The next few on the note packet, you need to do the empirical first, find the lowest ratio. So then you're starting with this step right here. For example, they don't give you at C3H2O. You would need to do the empirical formula first from the previous video. Once you get that, then find the molar mass of it like I did here on the left side, and then divide the molecular by the empirical. Thank you guys for watching as always.